Good evening, dear participant, and welcome in this session. Today, in this session, we will discuss about the control statements, which are highly useful to write different type of programs and to control the statements. Mainly, these control statements are used to control the flow of the statements. Once again, good evening, all of you. And if I am audible to all of you, please let me know. Good evening. Okay, I hope some more participants will join shortly. And first of all, I feel very sorry. Yesterday, I was not able to start the session at the right time. That's why I have to postpone for today. Dear Jinder, I am fine now, and I am able to take this lecture. Okay, and the control statements which we are going to discuss right now in this session are very helpful. You need to understand all these statements which we are going to cover in the session. These statements, these control statements are highly used to write a nice program, because many times we need to control the flow of the statements to write a long program. And the statements which are including here are if and, if else and, nested if and, if else, switch statements, switch case, nested switch case. Okay, and along with we will present here examples which are related to mathematically also. Okay, so first of all, I think I should share the screen with you. This is my MATLAB window, you can see here, and here are what I have done. I have write all the programs related to the said statements which we will cover in this session, so that in this session we can cover all these control statements in very less time. Otherwise, it required about 2-3 hours. Okay. My window is not visible to all of you. I think now my window is visible. Please let me know if my window is visible so that we can start. Okay. Please let me know if my window is visible. Still, it is blank. And now, please 1 minute. 1 minute, please. I am checking. Media source. Display capture. Okay, I hope now the screen is visible. Okay. Now my desktop screen as well as yes, thank you. Thank you to let me know that the screen is visible now. Thank you all of you. Okay. So the thing is, first we are discussing about if statement. Okay. And if statement is very simple to execute. This is only one condition is there. If that condition is hold only, then this statement will work. Otherwise, this statement will not execute. See here, you can see here are some statements, and sorry, what you can see here, these are values of A, B, and C. These are values of A, B, C, and mainly these are the coefficients of the quadratic equation. Okay, so the coefficient of x square is 1, and the coefficient of x is also 1, and C is equal to 4. And this is the discriminant. Okay, this is main our statement. So here we are going to apply if condition. Okay, so the if condition block will start from this place. You can see only this is the if block condition. This statement will work only if the value of this statement is less than 0. Okay, when the discriminant is less than 0, only this block will work. Otherwise, will not work, because this is the required condition. Okay, all the conditional statement or expression will be written at this place with the condition. Okay, and after that, this is the part of the statement. This is the statement. Whatever we can include here more than one statement, you can use two statement, three statement, whatever you have the statements corresponding to this condition. Okay, and then we end at this place. Okay, so this is the condition, and this condition is based on this one. Okay, so this is the function for discriminant, which is b square minus 4ac, and after that we want to display our result. This is the display is used for display the result. See here, I want to run this code. Okay, this block has been selected, and from this place you can see discriminant is minus 15. Okay, and along with you can see here discriminant is negative and roots are imaginary. See here, so as you can see discriminant is negative, that's why minus 15, it means discriminant is negative. So this statement is printed at this place. Okay, if discriminant is greater than 0, see, if we have discriminant is 0, I am changing the values of A, B, C, which are the coefficient of quadratic equation. If I take here 4, and this is 2, this is 2. So when you can see here that discriminant will be positive, and see what happen. If I run this block, these statements, okay, see the result, what will happen. Here you can see the value is only 8. Only 8 appeared. It means this condition did not executed, because this will be applied only if discriminant is less than 0. Okay, so here the value of this discriminant is greater than 0, so we have this value is printed in the desktop. And if we have the discrement is less than 0, then this block will work, or this block will be executed, and the results which will be here will be displayed at this place. Once again, you can change this value. If I have this value is 2, then you can see that discrement will be negative. Okay, and then this will be displayed in the desktop. See once again. Yes, you can see this is a warning. Discrement is negative. Roots are imaginary due to discrement is -4. Also, we have, I think this is very clear, all of you. And if you have any questions, you can put your questions in the chat box. I will try to justify your questions. Okay. Now here is also what you see. We are using if else. Okay. There is a little bit differences between this. So here we are using if else, and example is same here. Okay. So what is there? The values of ABC are at its place, and this is the discriminant. You can see this is the discriminant. So if discriminant is less than 0, if discriminant is less than 0, then we have this message. This will be executed according to this condition, and else is used for the other condition. Okay, otherwise, whether discrement is equal to 0 or greater than 0. Okay, in that case, this statement will executed automatically. Okay, so see, we are going to check it when we have on the basis of one condition or the other, because you know discrement will be either less than 0 or greater than 0 or equal to 0. So here we are going to apply only one condition. If discrement is 0, then what we want or what should be? This is the result. And if we have discrement is either greater than 0 or equal to 0, in that case, else. Else is used for otherwise. Else means otherwise. Okay. So in the case of other, there are many conditions, depends upon the function. Okay. So all those will be considered at this place. So else, then discriminant. So when discriminant is equal to 0 or greater than 0, in that case, roots are real, but may be equal. And equal will be only if when we have discriminant is equal to 0. See what happened. We want to execute this block according to these conditions, and note all these very carefully. Note all these statements very carefully in this block. I can maximize it. Yes. So when I will execute, roots are real, but may be equal. If you want to print the values of discrement, then you have to remove this semicolon. Okay. See once again. So now you can see value is 49. It means discrement is greater than 0, and only this case is displayed. Only this case is displayed because discrement is greater than 0, and you can see at its place. If I do like in this case, you can see, suppose I am choosing here, this is 2. Okay. So what happened? Now the discrement will be negative. Discrement will be negative, as you can see, corresponding to these values. And when I will execute this block, yes, you can see discrement is negative, and this is the displayed value. See here. See at its place. Only this part of the block displayed the result. Now the result discriminant was negative. That's why this statement executed and this value was printed. Okay. Sorry, this was the part. Yes, sorry. Because in the single file I have all the three conditions. So now you can see discriminant is less than 0. That's why only this statement was executed. And if we have the discriminant is greater than or equal to 0, in that case, this statement will print or display. If you have any question related to these conditions, you can put your question in the chat box so that if you need more justification, I will try to expand it. So many statements are there. This is a very simple examples related to if-else, and we can use these control statements in many ways. We are going to cover many control statements, loop, nested loop, switch, okay, for loop. So all these we will cover in the single session. Here you can see we have if, else, if, and else. So if and else if is used when we have more than one condition. If you have two condition or three condition or more conditions, okay, only then we can use this one. See here, this is very simple example at this place. Yes. So here the example is same. Why I am choosing here a single example, so that you can compare all these different type of application of this if and statement, if else statement, and if else case. Okay. So here we have if and else if. If is used for first condition, else if used for the other conditions. Okay. And else is used for rest other part. See here. So here is a discriminant. Okay. If discriminant is less than 0, then this is the result. Now we have other condition. What if discriminant is 0? For the second condition, we are using else if. And this is the expression of the logic. Okay. This part which I highlighted at this place is the logic expression. Also, you can use here bracket. Bracket can also be used at this place, like in this way. So there is no difference whether you are using bracket or not. So this is the second condition. This is the second condition. Okay. So less than is logic expression. Here is discriminant is equal to 0. Note this point. When we have equation, in that case we will use double equal sign. You can see here, here is double equal. Double equal is used for equal to, for logic condition. Okay. So when discriminant is equal to 0, then we know discriminant is 0, roots are repeated, or you can say roots are equal. Okay. So you can write what you want to display, or corresponding to this condition, what you want to use or what you want to print. Okay. So this is used at this place. And the third condition, now if discriminant else. Okay. So here we are using two conditions. One is discriminant is less than 0. Second is discriminant is equal to 0. And third one is discriminant is greater than 0. Okay. For that we are using here else. So if this condition is justified, then this value will be printed. If this condition is satisfied, then this result will be printed. If otherwise, this result will be printed. Now you can justify or verify block-wise application. See here, what I am doing, we have the values of we have the values of, this is the complete program for discriminant, and all the three conditions are used at its place. If discriminant is less than 0, discriminant is equal to 0, discriminant is greater than 0. For all these three, we are using here as if, as if, else condition. Okay. So note this control statement, and this control statement is used at this place. Now we can do experiment and we can check it whether the program which we have written at this place is correct or not. And according to, in the beginning, you need to check all these things to write a program, whether your program is working properly or not. See, I have A is equal to, B is equal to 4 and C equal to 1. Okay, when I run this program, I remove from this place semicolon because I want to check the value of the discriminant along with the displayed value. See, I run this block. Okay, when I run this block, you can see the value of discriminant is 8. This is the value of discriminant. Okay, and which is greater than 0. See, when discriminant is 0, so this part is justified at its place. Why? 8 is not equal to 0, 8 is not negative. So first two statements are not executed. Only this statement is executed because this is the otherwise. Okay, first condition not justified, second condition not justified. Only we have third condition, which is for greater than 0. See, if I have discriminant is equal to 0, so discriminant will be equal to 0 only if at its place I have 1. Now you can see discriminant will be equal to 0 and this result must be displayed. If this result is displayed, then we can say the statement is correct. See, just 1 minute. I have 4 and at this place I have to take 2. Yes, sorry. See now, yes, you can see discriminant is 0 and this result, else if discriminant is equal to 0 and this condition is justified and this result is displayed. Okay, now if discriminant is less than 0, I want to display this result. Okay, because there will be many cases we need to give only input and according to that our result must be displayed. So if the result at discriminant is less than 0, then this statement will be executed. See, I am changing the value. This is 4 and this is 2, this is 3, and according to these values I think the discriminant is negative. See, now the discriminant is negative. This condition is satisfied. This result is printed. This result is printed at its place. Okay, so in this way these statement will work and we can easily use if and condition, if else control statement, and if else if else condition. I think these statements are very yes, we can write the program. It can solve the equation with the complex root. Yes, we can write and we can find out the solutions also for the complex root also. Okay, so first the thing is I choose here simple examples so that you can understand this simple logic. Once the concept about this logic must be clear, and only then we are able to write and we can use according to our problems, because there are many statements and all these control statements play very important role to control our program flow. Okay. See here, I am using, I have one more example here. Okay. Yes. See this one. See here. Okay. So you can see at this place, if we have a function like fx is equal to x square, if 0 less than x less than 2 and x plus 1, if 2 less than and equal to, sorry, if x is greater than and equal to 2. Okay, then write the program for this one. So what we do here, we are using at its place if else, because here are two conditions. Okay, so we are using here if else function, and we can use. So what is there for this one? This is first condition. Okay, so 0 less than x and less than 2. We have two conditions. One is x is greater than 0 and second is x is less than 2. So see this one very carefully. If x is greater than 0 and x is less than 2. So we are using here and also both condition must be executed at the same. So and is used also at its place, so that both the conditions must be satisfied at the same time. Okay. So yes. So here both the conditions are satisfied according to this one. Now if this condition we have, then function is equal to x square. So this is the value of y. Y must be equal to x square. So this value must be stored somewhere, and we store this value in y. Else means when we have x is greater than and equal to 2. Okay. So for other conditions we have this one. Now we can check this program. We can check this program for this one. See. So we choose at its place x is equal to 1.5, and when I will execute this program, I have 2.2500. If I have at its place 2, then see carefully, I have is equal to 4. Okay, but here we have x is greater than 0 and x is less than 2, means x lies between 0 and 2. So this part will not execute, only this part was executed. 2 plus 2 we have is 4, but we have x square is also 4. Okay, so what should I do? If you choose here 3, you can check by using 3 and run again. You can see here is value is 4. So according to this equation, 2 plus 2 we have 4, and if you choose here 1.5, okay, and execute this one. So this statement is now executed because is less than 2. Okay, x is less than 2. So this statement is executed. So according to the conditions, the statement will execute. Which condition is going to justify? If this condition is satisfied, then this statement will execute. Otherwise, this statement will execute. Okay. Yes. And if I change the value, if I have 3 and 3 is greater than 2, so this statement not satisfied at its place, this will execute. You can see 3 plus 2 is equal to 5. I think you got it. It is clear, all of you. If you have question, you can put in the chat box so that I can give more example. Yes. Now, loops and nested loops. Okay. So here many examples are there. We try to present here. So why we need loops? The most important thing is why we need loops. So here are some reasons and importance, and according to that, one by one we will discuss here. So loops are one of the most powerful tool at your disposal. Just 1 minute. These text must be readable sometimes. Yes. So loops are one of the most powerful tool at your disposal as a program, loops arrow. And you can execute the statement or the group statement multiple times. These are used for variety of purpose, including these are the main reason why we need these loops. First is repeating a task until some condition is met. Sometimes we need to execute one statement many times, okay, to repeat the calculation. Then second reason is performing an operation on every element in array, okay. And third is building up an array by adding element one by one. Sometimes we need to create an array by adding. One is while loop, second is for loop, and third one is nested loops. So these three loops are used in MATLAB to write a different type of programs. Okay, so here are the syntax for the loop. Okay, so why we need while loop? A while loop is a program language control structure. It executes statements repeatedly as long as a specified condition is proper. Okay, so this statement will be executed as well as when we have the specific conditions are satisfied, and this is the syntax for the C, and at its place we have the expression, we have the logic, and then we have the statements. Okay, so all the statements will be at this place. All the statement will be at its place and then end. So this is a very simple syntax for while. We have example for while loop. Yes, you can see this is the while loop. So this is the very first statement, CLC clear, we usually use at its place. And here is x is equal to 10, y is equal to x plus 1. This is the function. Okay, while x is less than and equal to 10. So this is the logic. And y is equal to 2x. So the meaning is that this is the function, and for x is equal to 10. Okay, this condition will be executed until we have 10. So we are going to start from x equal to 1 and y is equal to 2x. Okay, so until this condition is satisfied, we have output or result corresponding to this one. Okay, see here. Just 1 minute. Publish. Display. Just 1 minute, please. Open it. Just 1 minute. Okay. And then run it. We have 11. So 10 is, this condition is not justified at this place. Okay, when we have x is equal to 10, then this statement executed. And if we have at this place 12, and again we run this program, okay, it's still busy. It is looking still busy. While there is some error at its place. Just 1 minute. Loop. A equal to 1. This is the nested loop. Two. There is some mistake in this program. What is this one? This is for loop, while loop. Okay. See here. See this one. See this one. So here is while is used, and also this is nested while loop. Okay, both the things are here. We have X array, and second is Y array, and N. What is N? N is the length of X. Okay, this will return the length of X array. Length function is there, and this will return the length of this array. Okay, similarly, M is length of Y. How many elements are there? By using this one, we will get the number of elements in X array. We can increase or decrease corresponding to this. Okay, now we are going to initialize I is equal to 1. Okay, and J I is equal to 1. This element will be there while I is less than and equal to N. Okay, so this while loop will work until we have these are 5 elements. Okay, it will choose only first value, then second value, then third value, then fourth value, and fifth value. Okay, so we want to initialize this loop from I is equal to 1. Okay, so while is there, this will work until we have n is equal to 5. So we applied at this place condition. And second loop for y, we want to pass this value also. J is equal to 1. Okay, we want to initialize j also. J is used for this array. Okay, and m is the number of elements in this array. Okay, so j will execute only then until j is less than and equal to m. Okay, so from this place we have the value of m, and which is 5. So what is the use of these two statements? First it will take j is equal to 1, then it will take 2, 3, 4, and last value will be 5. Okay, so these are the reason to use for this array and this array. Now what we want corresponding to these values, a is the expression and using the index of I and j. Okay, so I and j will be taken at its place, and this operation will be executed xi. Xi means first value of x array. Okay, so when we have I is equal to 1, then this value will be taken. When we have I is equal to 2, this value will be taken. When we have I equal to 5, this value will be taken. And similarly for this one. Okay, yj. So y1, y2, y3, y4, y5. This is the y1, this is y2, this is y3, this is y4, this is y5. And we want to multiply all these. Also in the case of while, we need to use also loop for loop for j. Okay, j, first we are taking at this place j is equal to 1. So it will at this place we have j is equal to 1 and 1 2. Okay, because for the next value we have to apply at this place loop also. Okay, so first this will calculate for j is equal to 1 at this place, then it will increment to 1 unit, 1 and 1 2, then it will calculate. So note this one very carefully. First it will take j is equal to 1, this value will pass through this one. Okay, and it will calculate, and also at this place when we have j is equal to 1 plus 1 2, and it will go at this place. So this value again will pass through this one. So in this way this while loop will work until we have the value of j is less than and equal to m. Okay, similarly when we have I is equal to 1, this value will pass through this one. Okay, and this value after